Today's lesson's on section 9.5, and it's day 2, where we are now factoring and solving some quadratic equations. We talked about in previous lessons what happens. We did a few problems where what happens if I don't have 0 on one side by itself, like the problem I've got here. Well, in this kind of situation, again, as we're learning right now, the best way to solve these types of equations is we do have to get it solved for 0. I need to have everything on one side and 0 on the other. So everything over here, and it all equals 0. Otherwise, right now, that's the best technique we know. It's not going to work if we don't have that. So in this problem, we need to solve it for 0 and collect kind of like the like terms as we go. So let's say we subtract 5 from both sides of 2x squared equals 30x, and then plus 68, okay? And as we're going to find out now, it's nice to have, at this part here, there's a couple ways I could do it, but it is nice to have your leading coefficient be a positive number. If it's negative, there's ways around that too, but I like to leave that positive. So right now I'm going to move the other two terms over to the left side. I'm going to kind of in one step here subtract 30 and subtract 68, move them both over here kind of in one step. So I'm going to end up with, as you can imagine, 2x squared minus 30x minus 68, and all that equals 0. So I kind of have to collect the like terms and get this solved for 0. And now I can use our method of trying to factor so that we can solve these quadratic equations. So a problem like this, now remember there's two kind of main ways we've learned to factor, and both equally important. The first thing I should look to do is see if I can take something out of each of the terms. And yeah, in this case, I can take out a 2 from each of these. Everything divides by 2, so I'm left with x squared minus 15x, and then minus 34. And then all that equals 0. And now I can factor this 34, well, just everything, this trinomial. But now I've got smaller numbers to work with than what I had up here, and I factored out that 2. That made my life easier. Now I can try to factor into 2 binomials. And when I do that, it still all equals 0. This 2 really is still out front. We're going to find out that doesn't influence our answers in this case at all because there's no variable with it. But it is still important to have it out there. Really, it got factored out to start. So it's important for now. Then I need factors of 34. Well, there's 1 and 34 and 2 and 17. I think 2 and 17 is going to be my combination. That's going to get me to negative 15. So I'm going to have x and x. I'm going to have minus 17 and plus 2. So x minus 17, x plus 2. And so my solutions for this one are x equals 17 and negative 2. Okay, I'll walk through just a couple other examples just to, again, show what we're doing here to make sure we got the idea. Again, what happens if I don't have everything on one side? Can this still work, this way of solving by factoring? Right now, the truth is no. I need to, for the method we know right now, factoring, I need to get everything on one side. I have to collect the like terms and solve this equation for 0. So as you can see, I'm doing that right now. I'm minusing 10 from both sides, which will make 0 on the right side. Now I'll be able to solve this equation. X squared plus 3x minus 18 equals 0. Again, in the habit of I should look and see, can I factor something out of each of these terms? In this case, no. There's no other leading coefficient. There's no other number here in front that I can see in front of x. It's just a 1. I don't have like an x to factor out of everything, so I can just start factoring now to 2 binomials. Again, it's x squared, so it'll be x and x. Factors, again, I have 1 and 18, 2 and 9, and 3 and 6. And I think 3 and 6 are going to be my combination because this is minus 18 for this one when I look at the sign there. So that means I'm going to have 1 of each sign, a plus and a minus. And I need to get to positive 3 for the middle term there, as you can see. So this should be plus 6 and minus 3 should be my combination to factor. Now I can solve and say x equals negative 6 and positive 3. There are my solutions. Okay. Let's look at one more here on this page. So again, same thing. I need to get this solved first. So I have to draw my line. I've got to bring the 8 over, otherwise it doesn't work. In the future, we'll learn there is something we could possibly do there, but right now, this is the best way we know. We have to get the terms collected, like terms collected, and I have to have it solved for 0. Then I can use this factoring technique. X squared minus 23, or sorry, y squared minus 23y plus 42. Okay, I'm going to start to factor again. I'm going to have 2 different sets of binomials. And I'm kind of skipping ahead to that because I can see that I don't have a leading coefficient out here, right? It's just 1. I don't have a y that I can factor out every monomial, so I'm just going to go right to where I'm factoring the 2 binomials like I did here, okay? They'll start off with y and y. I'm just going to list my factors of 42 over here because I have a little more room over here. 1 and 42, 2 and 21. Oh, I think already I'm just going to stop because I think 2 and 21. That's going to be my combination that gets me to negative 23, right? And it makes sense, yep, because this is positive 42. So that tells me my signs are each going to be the same thing. They're both going to be, in this case, minus signs. And yep, I think minus 2 and minus 21. That will get me to negative 23y. So that must be the correct factoring. So y equals 2 and 21 as my answers. On the next slide there is some notes for you to copy down. Pause the video if you need to right now, but I'll just kind of briefly talk to it. It says here's like the steps then that you're looking to do when we're trying to solve a quadratic and we're using factoring to do so. Step 1, like it says, just like we've been doing these examples. First, if we can, we look to collect the like terms as we get everything solved for 0. If we can get to that point, that's going to allow us to set something where we can factor and use that idea that the things have to multiply together to give me 0, so I can pick out the numbers that will make that happen, the solutions, the roots, okay? So first I have to collect the like terms as I solve the equation for 0. Second thing is, first, we learned 2 different ways to factor, and these you have to look for both of them. At least it'll make your life easier if you do. First, see if you can factor out just a monomial. See if you can factor out one term, and again, that's kind of like reverse distributing. So see if you can just factor one thing out, whether it's a number or a variable or a number and a variable. But that will make things a lot easier as you go through the problem. And then step 3, look to factor then. After you've done number 2, look to then factor into 2 binomials. Again, that's like reverse of FOIL, or reverse of table method, where you end up with the 2 binomials, and that's called factored form, which is maybe just something to jot down that eventually we're trying to get to. Factored form, so we can solve. One more note on this page just to realize is that sometimes you will do step 2. Sometimes you will do step 3. Sometimes you will do both step 2 and step 3. It just depends on the problem. So, but you should look to do number 2 first, and then look to do number 3 next. And again, sometimes you'll do both. Sometimes you just do one. It just depends on the problem. And the last examples of this method is just realize that they give you some problems, I know, in the upcoming assignment that talk about finding the zeros of a function. And realize this is just actually the same things we've been doing. When you find the zeros of a function, you're finding the values of x that you could put in so that this whole function would equal 0, okay? Well, really what that's doing, or whenever you see something where you're trying to find the zeros of something, it's pretty much just telling you that you should take this thing and set it equal to 0. So if I rewrite this problem, really what it's saying is, find out when x squared plus 10x plus 9 is equal to 0. What values of x will make that happen? And what do you know? That's exactly what we're doing right now. The way we can figure that out is by using our factoring technique. And nice enough, if you do a problem like this, by setting it equal to 0, you've already done like the step 1 from the previous page. So you're done with that. You have it set equal to 0. And now we look to do our factoring. And this first one will factor to, just kind of skipping through here, this first one will factor to x plus 1 and x plus 9 and x plus 1, so all equals 0. And so then I can say my solutions are negative 9 and negative 1. So finding the zeros of a function, as it says up here, again, one more example, is just saying, well, figure out what values will make this function, f of x, will make it equal to 0. What values of r will do that? Well, the way we do that is then by taking that function and setting it equal to 0. So r squared minus 10r minus 24 equals 0. And this one, then we just do our steps 2 and 3. Can I factor out a monomial? Well, not in this one. Can I factor it into two binomials? And yes, I believe I'll be able to. Here's r and r. It's equal to 0. Just kind of skipping ahead here. I think it's going to be minus 12 and plus 2 will be my factors of 24. They get me to negative 10. And so this one will be r equals 12 and negative 2. So when you see these problems that say find the zeros of the function, don't be too worried. It's very similar to what we've been doing. You're just setting the function equal to 0 and using the technique we've learned to factor and solve.